Energy consumption is on the rise. Buildings consume almost a third of our global energy use and produce 20 to 30% of greenhouse gas emissions. The built environment of our cities is demanding more and more of us. We, in turn, must look at how this energy demand shape our usage, and we are then able to look at how to optimize and better make our buildings more efficient. My name is Caitlin Ng, and I'm doing research in the Intelligent Environments Laboratory. This project is called CityDNN. The goal of our research is to determine the thermal losses and solar gains of a building due to a variety of external factors. In other words, this means that we will look at building heights, the orientation of a building, trees, and weather to see how this will all affect the heating and cooling capabilities of a building. For example, take a sundial. As the sun rises and sets, the shadows change size and direction. In a city, buildings act similarly. They cast shadows and are shadowed by others depending on the factors such as trees, orientation, and height, and these shadows play a role in the heating and cooling of a building. As you can imagine, standing in the shade is always much cooler than standing in the sun, and this can then be applied to buildings and be used to the human advantage to optimize energy costs through things such as air conditioning. Currently, we are building an urban energy model through coding in Python and using programs such as QGIS and CitySim to simulate our energy usage. We begin with the city of Austin and use this data to create a program that will be able to determine how building and weather properties affect energy usage. This model will then be expanded with things such as machine learning and deep neural networks to allow it to be applicable to the urban energy use of any city. Research like CityDNN is one of the many ways that allows us to make our infrastructure smarter, more resilient, and more efficient, and helps us to be more environmentally sustainable over time.